We're okay with time. So I handed out the homework, okay? And because part of my lecture, I'm going to actually do probably 2 problems on the homework. But before I do, we've got to understand some. Well, let me just look at this for a second and see which one I want to do. Let's say I'll do number 4, and then we'll talk about how to do certain ones. But we're going to do number 4 on this homework assignment. Number 4 says 6n. Where am I? Oh yeah, minus 0.08 equals 5.90 n minus, did I do that right? Oh, that's an 8, sorry. And I'm doing this, okay, minus 0.2. All right. So when you do these, that looks like kind of complicated, doesn't it? I mean, just like, you sort of roll your eyes at this point. You think, oh, great, decimals, right? Well, decimals are really easy. The trouble is, it's confusing to do it this way if you just did it the way it is. And it's totally fine to do it this way. You can just leave it in decimals. If you love decimals, go for it. But I'm going to show you an easier way, okay? It means you're going to use larger numbers, but it's okay. What is the rule? If I had, like, let's say I had 2.5 in an equation equals x, and I wanted, well, equals, let's see, let me do this differently. Equals, well, you know what, I'm not going to worry about an equation right now. I'm not going to worry about that. But if I multiplied this times 10, what would happen to the decimal?
It would disappear.
The decimal would become it would be the exact same size.
I would move the decimal which way? By multiplying times 10, Mira? To the right. Is that what you meant?
No.
Okay, so look, if I multiply this times 10, look what happens. This decimal moves over here, so the answer is 25.
Everything I know is wrong.
But it's really easy. It's easy. When you're multiplying times 10, how many zeros is it?
1.
So the number of zeros is the number of spaces you move the decimal to the right, right? So if I had 2.64 and I multiplied that times 10, what would it give me?
26.4.
26.4. Now, what if I did 2.64 and I multiplied it times 100? 2 zeros. I would move it over 2 places, so the answer would be 264. That's kind of cool. So when you're dealing with equations, anything goes as long as you do the same thing to both sides, right? Right? Remember that? If I do something to the right side, then I have to do the same thing to the left side, right?
Yeah.
The golden rule of algebra. Whatever you do to one side, you have to do the other. Then it stays equal. It doesn't necessarily stay the same, but it stays equal. They stay equal. And then we solve it, and we'll always get the same answer. So I look at this, and I think, I don't really want to deal with 0.08, and I really don't want to deal with 5.98. I'd rather deal with whole numbers, integers, right? So I'm going to get rid of the decimals, and I'm going to turn them into integers. And so I am going to multiply this entire equation by what? By 100, right? And that would get rid of all my decimals. So if I multiply it times 100, right? 6 times 100 is 600n minus, what is 0.08 times 100?
8.
8, right? That's kind of easy. Equals, what's this?
Would be 598.
598
N.
n minus, what would that be?
22. No, 20.
20, right? Minus 20. Okay, so that now it's not so hard. Let's subtract. I see I have 600n over here.
Wouldn't you?
I have 598n over here. I don't want them on both sides, on opposite sides of an equal sign. Ben.
Wouldn't you have to add it because there's a minus sign there?
Yeah, but what's minus? It's the 20 is minus.
Okay.
This is a positive 598.
Well, how do you decide if it's adding, subtracting?
Because if it does not, that's a great question. If it does not have a sign in front of it, in front of this, the sign that affects this is the sign that's in front of it, not the sign after it. It's the sign in front of it. And if it has no sign, you automatically assume positive. So that is a plus 598n. So I've got to do the opposite of that. I could do negative 598n. And I'm going to do the same over here, negative 598n. Oh dear, that's a hard problem. 600 minus 598, that's huge! Right? All right, so we got 2n minus 8 is equal to negative 20. Oh my god, this is so much easier now. Look at this. Right? So much easier. I'm going to add 8, right, to both sides. Add 8 to both sides. 2n is equal to, negative 20 plus 8,
Negative 12.
negative 12, right? Then I divide by 2, n is equal to negative 6. And we have solved our problem.
So
Pretty straightforward, right? Pretty
you just
easy.
multiply
Yeah.
by 100 every time.
Well, if I had wrote it at 0.8 and 5.9, then I would just multiply everything times 10.
Okay.
Do you see what I mean?
Yeah.
It depends on what's in the problem. If it was 0.008, I'd multiply everything times 1,000, right? Now, let's do one more problem.
Can you do number 7 because
Yeah.
it needs distributed properly?
Yeah, let's do that exactly. That's the one I was thinking of.
Yeah.
So we're running out of time, but we're going to do that really fast. 7 or an 8? All right, yeah, well, that's fine. We'll do 7. You want me to do 8 or 7?
No, 7. 7. 7.
What? All those in favor of 7,
No,
raise your
do
hand.
8.
Do it.
All those in favor of 8, raise your hand. Okay, 8 wins.
I
Okay.
just get my hand up. I'm like, I don't care
Okay.
at all.
So we got 9.92 minus 0.12 parenthesis x minus 3 parenthesis equals 0.4 times parenthesis 2x plus 5. Okay? All right. I have to look, okay, this says it's just 0.4, so I can multiply that times 10. But would that get rid of my decimals? So I have to look at the one that has the largest number of decimal spaces, right? Spaces after the decimal.
Okay.
And so I have to multiply everything times
100.
100.
So you do
So-
that before you do the.
So I'm going to multiply this whole thing times 100. I'll use brackets instead of parentheses,
Wow.
just so that they're clear. And then 100, right? So what is this times 100?
992.
992 minus, now, what is this times this? 12. Now, do I have to multiply this now times this? No. Why?
Because it's in parentheses.
Because this is being multiplied times this. This is technically one term.
So it's.
Even though this has a minus sign, it's in parentheses, it's 2 terms. But because of the parentheses, it's sort of considered one term, this times this, right? So that's one term, so I'm only multiplying it times the 12. You guys see that?
Yeah.
And then, then x plus minus 3 equals 100 times 0.4,
40.
40, parenthesis, just 2x plus 5, right? And now I just use my distributive property. So I've got 992. Now I've got minus 12 times x. Do not forget about this minus sign. Minus 12 times x is minus 12x. Minus 12 times minus 3 is minus 12 times minus 3 is plus 36, right?
Yeah.
Equals 40 times 2x, that's 80x, plus 40 times 5, that's 200.
I would add 12x.
Oh, wait, what?
So, what?
Oh, never mind, I get it.
Okay. All right, does that make sense?
Yes.
So now I see, oh wait, I've got my x's on 2 sides. That's the first thing I'm going to deal with, yes.
When you do the distributive, how do you do the first one? When you do 12x minus
Good question. Notice the 12 has a minus sign in front of it. So think of it as negative 12 times x, which is negative 12x. Negative 12 times negative 3 is positive 3. Do you see? That's a common mistake. I'm glad you asked that. So now I look at my x's. I'm going to just move my negative 12x to the other side. Add 12x, right? Add 12x. suddenly, that doesn't look like an add 12x, geez, whatever. Okay, 992 plus 36, well, I could have added that, equals 92, right? X plus 200. So this, I could subtract 200 right now, so I'll do that. So that's 792. 792 plus 36 is equal to 92x. I'm just doing this really fast because of, and then I add those, and then I divide by 92. Okay, you got the idea,
Add.
right?
Yeah, add.
I would add these two together because they're on the same side. 792 plus 36 is what?
How's it?
What is this? 36, 7, 8. Let's see, this is 8, and then 12, right? 828. So 828 equals 92x. Divide by 92. Divide by 92. X is equal to what? 9. Beautiful. Good job. Excellent.
Do we have to show our work on the paper on those now?
Yes, show your work.
No,
I
on
do
the
not
paper.
want weird stuff. I want you to go down one line at a time and show me your work as you
You
do it.
gave us the answer, but then you don't let us, like, but then you make us show our work.
Well, not on this one. You don't have to do this one again.
What about that one?
Well, this is this one. That's
Oh,
all one.
duh. Okay,
Right.
never mind.
But you don't have to do that one again. You just do the others, okay?
Like